Assalamualaikum warahmatullahi wabarakatuh. My name is Syami Midaya binti Sulaiman, UK 35690. First of all, I would like to thank you to Dr. Hasila for giving me chance to finish my video. My video is about the importance of variation in stochastic calculus. Total variation. Given a function f t more than or equal 0, the total variation of f over the interval 0t VTF is defined as VTF equals supremum n element p summation of k equal 1 to n absolute ftk minus ftk minus 1 if VTF less than infinity. For any t more than or equal 0, we say that f is of bounded variation and we denote it by writing f element bv. Second, quadratic variation. In generally, given a function ft, t more than or equal 0, the quadratic variation of f over the interval 0t, qtf is defined as qtf equals supremum n element p summation from k equal 1 to n absolute ftk minus ftk power of 2. We have that if f element bv, then qtf equals 0 and that any function with non-zero quadratic variation has infinite total variation. In case of a stochastic process at t more than or equal 0, the definitions for total variation and quadratic variation stay the same with the only remark that the limits are intended in probability sense. Quadratic variation is also used in stochastic process such that Brownian motion and martingale. In Brownian motion, infinite quadratic variation for every t more than 0 in the classical sense of taking the supremum of the sum over all partitions. The quadratic variation function of the standard Brownian motion Bt is given by Bt equal t. Brownian motion has Ito process and Ito integral. First, Ito process. It can be generalized to Ito process that can be expressed by Ito integral. Xt equal x naught plus integrate from 0 to t standard deviation dB plus integrate from 0 to t mu ds, where b is a Brownian motion, while the process for quadratic variation at t equal integrate from 0 to t variance ds. Second, Ito integral. For Ito integral, given the standard Brownian motion bt t more than or equal 0 and an adapted stochastic process at t more than or equal 0, satisfying the condition. Let xt be a regular adapted process with probability 1. Integrate from 0 to t x squared t dt less than infinity. Then Ito integral integrate from 0 to t x t dbt is defined. Since it is a random variable for any fixed t, integrate from 0 to t x t dbt has a function of upper limit t defined a stochastic calculus. Lastly, martingale. Quadratic variation were defined by local martingale. It can be shown that the quadratic variation m of a general locally square integrable martingale m is the unit right continuous and increasing processing starting at 0 with jump m square minus bracket m is a local martingale. Square integrable martingale is the Ito isometric, which can be used to calculate the variance of Ito integrals. Expected integrate from 0 to t htm square equal is expected integrate from 0 to t square dm. That's all from me. Thank you.